So, of course, one of the most famous examples of simple oscillations is that of a simple pendulum. So this video is about how to think about simple pendulums from the perspective of mass spring oscillators. Okay, so let's draw a simple pendulum. Here we have the ceiling, we have, this is the vertical, and then the pendulum itself. So let's say this is length L, mass M, okay, and then of course gravity G, and you can derive the equations that govern the simple pendulum. I'm not actually going to do this right now. I'm just going to write the equations of motion directly. You would use techniques from homework 4 to derive equations of motion for this. But in any case, let me just write down the equations of motion. So the equations of motion, once you write it out, is actually, it's going to be ml square alpha equals m minus mgl sine theta, okay, where alpha equals angular acceleration, if this is theta, this is alpha is theta double dot, okay, it's the angular acceleration. So you can use concepts from homework 4 or homework 8 to derive this equation of motion. Maybe at the end of this video I might actually derive this equation. So but let's just say we are given this equation. Let me call that equation 1, and then let's sort of rearrange it slightly. Ml square theta double dot plus mgl sine theta equal to 0. We can simplify this if we want, so we can divide through by ml square, and we get theta double dot plus mgl divided by ml square sine theta equal to 0, or theta double dot plus g over, looks like I'm using a different L, but doesn't matter. Okay, g over L sine theta equal to 0. Okay, this is sort of one of the most famous equations, differential equations in mechanics. It's the equation governing the motion of a simple pendulum.